in what? One of the types of binary code is numeric code. That is what weighted code. Okay, weighted code we study. So when I give example only, you can able to understand what is meant by weighted code. But before that, you know that what BCD 8421. In the previous slide, I have given no BCD 84. BCD 8421 is an example for what mark? The weighted code. Okay, and 5421 like that we are having. Okay, and so this only we are going to cover now. Okay, weighted code for that one of the examples BCD and all we are going to study now. Okay, so now in this, what is BCD now? See, BCD means what? Take the decimal symbol. The table I have given no. Take the decimal symbol 0, 1, 2, 3, 4 up to 9. Okay, all the decimal symbols you take now. Each decimal has to be represented in the form of 4-bit binary. What is BCD? Each decimal digit need to be represented in 4-bit binary number. That is what your BCD. Understood? So for 0, no, for 0. For the 0, what is the BCD? 4-bit. BCD means what? It is equivalent binary. I already said how to get the from the decimal to binary, how the conversion and all. That is why, my dear students, repeatedly I am saying, previous class content, if you don't know, you cannot able to understand DPSD. Okay. So when I used to say, yeah, what is the decimal for this one? What is the binary of this one? First table, number system, first table I shown. First table you are very clear. Okay, all the problems you can solve it easily, right? Okay. So now for decimal 0 means what is the binary? Decimal 0 means binary 0, you know. Its equivalent binary is also 0. Decimal 1, its equivalent binary is 1, you know. But decimal 2, its equivalent binary is what, ma? 1, 0. We studied already. But we need to represent in 4-bit binary. We need to represent in 4-bit binary. Be clear about this one. BCD means what? Every decimal digit has to be represented in 4-bit binary number. Understood? So this 0, no, this 0, how will you make into 4 bits? Add enough number of zeros here, means 3 more zeros. Then you can able to convert this 0 into 4 bits. Am I right now? Now this 1 you see, left side I am giving what? 3 more zeros. That only you are having here, no ma? That only you are having for 0 and 1. 0 and 1, right? For 2, the original binary is 1, 0. How will you make into 4 bit, ma? Left side, 2 more zeros you are adding. That is why you are having for this 3, for like that, for this 2 you are having, okay, in 4 bits. Okay, already you know what is the binary equivalent for all these decimal numbers. I will not repeat this again and again. Okay, already you know that what is the equivalent binary for this decimal numbers and all. Okay, so for 0, 4 bits, 1, 4 bits, 3, 4 bits. This is called now BCD equivalent. This is called now BCD equivalent of given decimal digits. Okay, not decimal number. Decimal number may be with 2 number digit, 3 digit, 4 digit like that. Here single digit we are having. For all these single digits, okay, the equivalent 4 bit is this one. Understood? That is why in BCD representation we say that up to 9, 0 to 9, up to 0 to 9 only is the valid BCD we say. See, up to 9 only is the valid. Why we say like that? Because 0 to 9 only we have single digit decimal. From 10 onwards double digit, 11 double digit, 12 double digit, 10 double digit. But we cannot able to represent we can represent in 4-bit binary. But what is the definition for BCD? Each digit of the decimal number need to be represented in 4-bit binary. Okay, so for you may ask the question for 10, 10, 10 is the equivalent binary. For the 10 decimal 10, 1010 is the equivalent binary. What is the definition for BCD? Not for these two digits combinedly. Okay, not for this 10 combinedly you can specify. No, you have to specify individually. For 1 separately you have to specify in 4 bits. 0 separately you have to specify in 4 bits. That is why we say that valid BCD numbers are from 0 to 9. Remaining we have to find out. We have to make. Okay. For 10, what is the BCD equivalent? For 11, what is the BCD? For 100, what is the BCD? For 1000, what is the BCD? We have to find out. Using these BCD digits, using these values, we have to find out. Okay, ma? Now, see here. So, for one example, how to find out the BCD? Okay, one example. See here. For 185. 185 with the base 10. 185. What is the base now given? See, what is the base given? 10. 10 means what? It is a decimal. 10 means what, ma? It is a decimal number. Everybody you know that, right? And what is the equivalent BCD? See that? Equivalent BCD. For this 5, what is the 4-bit binary? Tell me. For 5, what is the 4-bit binary, ma? For 5, this is a 4-bit binary, no? Am I right? 0, 1, 0, 1. So, for this 5, 0, 1, 0, 1 is, so each digit needs to be specified in 4 bits. Everybody you are understanding, yeah? Right. That is why you can able to put this is with the base BCD. It says this is in the form of BCD. Okay, now for 8 you tell me. For 8, what is the equivalent BCD for 8, ma? 1000, no? Am I right? Okay, that is the equivalent binary. So, for every single digit, equivalent binary. That is what here BCD is there. So, now for this 8, what is the equivalent BCD? Tell me. Same, this 1000, no, ma? 1000. Am I right now? Like that for this 1, you tell me. For this 1, 0001. Means the actual value is 1. When you are making into 4 bits, 3 more zeros are added. Everybody, you are very clear now. Very good. Okay. Then, so this is what BCD representation. For the same number, when you convert into binary, how do you say this is binary? Base is 2. Base is 2. It is what, ma? Binary. Understood? So, for 185, how will you find out binary? 185. I said already, no? Okay, you have to divide into 2. Like that, you will be following. You will be following. Right. So, this everything is studied. So, for 185. Now, for 10, you tell me, what is the BCD for 10? For 10. First, for this, 0, you have to write this side. Zeros. BCD is what? 4 zeros. So, 4 zeros is the equivalent BCD. Okay. Now, for this 1, you have to write here. Okay. First, this 0. Then, will be left side, you have to write for 1. For 1, you know, 0, 0, 0, 1. 0, 0, 0. When you are writing BCD, please give this much space between the digits. Okay, ma, see here the space is given, no? See here the space is given. Okay, so for clarity and also for representing BCD, you have to give here 1 or 2 more spaces here. 1 or 2 spaces. Okay, this is about what? Finding the equivalent BCD for any decimal number. Understood? Now, so far I didn't tell you about what is weighted code, what is non-weighted code. That I didn't say. I just told about BCD. Okay. So, what is the binary coded decimal? And one more thing, what is the expansion of BCD? Binary coded decimal. So, binary coded with the binary digits, zeros and ones. It is coded and it is called what? For the decimal numbers. It is what? BCD. Okay. Expansion, very, very important. Binary coded decimal. Okay, ma. Now, we see about what is the weighted code. Why do you say as weighted code? Understood? So, this one we see with the next weighted numeric code. What it is? See here. You just go through just this table, ma. What we said, it includes the BCD, It includes BCD as well as some other 5 for 2 1 also a given, 2 for 2 1 also a given, 8 for 2 minus 1 minus 2 minus 1. This is also example for what? Weighted numeric code. Why we say this is a weight value? See here, for every decimal, I said already for BCD with 4 bits only. Okay, for here this side you are having valid BCD digits. Okay, decimal digits 0 to 9, right now? Okay, so now you see for every position, for the zeros, for this first row, we are having equivalent weight here 1. For the second, we are having here the weight value 2. For the third position, we are having the weight value 4. How that weight value, I will tell you. First, you just listen what I am telling. For the fourth position, what is the weight value here? 8. Okay. If so, now you take the 5, 4, 2, 1. For the first position, some weight value is there, 1. For the second one, some weight value 2. For the next one, 4. Like that. Okay. Based on this representation, we can able to derive its equivalent digits here, its equivalent pattern or the code here. Okay. If you are using 2421, if you are using 2421, okay, then what is its decimal? What is its decimal 2421 representation for the decimal 0 or for the decimal 3, for the decimal 5. And for BCD you are calculating means what is the equivalent BCD for 1, what is the equivalent BCD for 2 and all, what is for 3, what is for like that. Okay, so every position, every bit position, it has some weight value. Understood, Amma? Now how this weight value comes? Okay, how this weight value comes? See, for example, so here we take that this is what decimal portion. Decimal I have, and here I have the BCD. BCD means what? It is in the form of 84214 code. Okay, that we write here. 84. This is what? 8421 code. So I write it here 8. Then will be 4. 8, 4, 2, then 1. Okay, 8421 code we are using. Okay. Now for the decimal you see, for example, for the decimal 0, for the decimal 1, for 2, for 3, 4, 5, 6, 7, like that. Okay, up to 8 and 9. Okay, ma? So what is the equivalent BCD? We are going to see that now. See, what you need to do now. Okay, what you need to do now? See, I want to calculate the binary for the decimal 6. For decimal 6. Okay, for decimal 6. What is a binary? Normally, how will you do? How will you calculate? How will you calculate the binary? How will you find out the binary for the decimal 6 month? You can do like this now. I can tell immediately it is 110. I can tell immediately this is what 110. If it is in 4 bits means you have to add one more 0 here. Am I right? But if you don't know means you have to calculate. What procedure I said already? You have to divide. 2 binary. Binary base is 2. So with that 2 I have to divide. Okay. So 3 2s are 6. So here 3 2s are 6. Remainder will be 0. Again this 3 can be divided by 2. Okay. So 1 2 is 2. Remainder will be 1. Am I right? So this 110. This pattern only we know how to calculate binary for the number. Understood? Now the one more interesting technique I tell you. Using 8421 code, using BCD, you can able to find out binary equivalent for any of the decimal digits. Okay, ma? So how? For the same 6. For the same 6 I take. That is how to find out now. What you need to do, these bit positions are there, no ma? This bit position. Am I right? Okay, these values, this 1, this 2, this 4, this 8 are called as weights. Okay, are called as what? Weights. For the particular position. These are called what? Weight values. For the particular position. Particular position means what? For the 0, what is the weight value? What is the least one? 1. For this 1st position, next position, the weight value is 2. Next weight value is 4. Next weight value, like that. Okay. So these and all we used to say that it is the weight value. Understood? It is the weight value. Now, for calculating 6, what you need to do to get its equivalent binary? Take this weight 8421. If you take which digits, you can get 6. When you add what are the digits, you will get 6. That you have to understand first. So when I add this 4 with this 2, am I right? What is the value 4 plus 2? When I add this 4 with 2, for what number I am going to convert a binary? I am going to calculate binary for 6. You are very clear now. For 6, I am going to find out the binary number. Okay, 6 is a binary number. So, this weight value pattern you are taking, when you add what are the digits, you will get the same 6. Okay, what we need to take? When I add what digit, I will get this 6. When I add this 4 and this 2. Am I right, ma? 4 and this 2, I will get what now here? 6 I will get. Any difficulty here? 4 plus 2 equal to 6. Am I right? So, where I put this line, ma? See, where I put this line? I put the line in 4, I put the line in 2. In that places alone, you have to put down 1, 1. Understood? Remaining positions, you have to put 0. Here 0, here also 0. Now what is the binary for the decimal 6? 0, 1, 1, 0, no? Am I right? That only I have calculated here, no? 0, 1, 1, 0. Am I right? Okay, so this is about what? This is about finding the equivalent binary, that is also equivalent BCD for every digit. Understood? Now, for example, if I give 5, for 5 I need to calculate. Okay, what value if I add, I will get 5, ma? Can you tell me now? What value if I add, I will get 5? Any idea? 4 plus this 1. Am I right? If I add 4 plus this 1, the answer will be 5. So 4 plus 1 is 5. Before calculating, I know what is the binary for 5. I know it is 101. When you make into 4 with 0, 1, 0, 1 will be for the binary for the decimal 5. Or the decimal what? 5. Yes. Now what I said, ma? What I said now? With 4 and this 1, when you add, you will get what here? 5. So how will you make the binary pattern? In this place of 4, put 1. In the place of 1, okay, 1 also you have drawn line, 4 and 1. In the place of 1, put 1. Remaining positions, put 0. Put 0. Any difficulty? Understood now? So how we are calculating? How we are calculating binary values using 8421 code. Understood, amma? Next, now you calculate for 10. For the decimal 10, what is the binary? First you tell me, without using this method, what is the binary? What is the binary? For 10, the binary is 1010. Am I right? 1010. Its hexadecimal equivalent is what? What is its hexadecimal equivalent? A, capital A. Am I right, ma? So this is in decimal, this is in binary, this is in what? It's the hexadecimal representation. Okay. Now, what is the, how do you verify your value? Now tell me, how do you verify this is correct or wrong? Based on your 8421 code, you can use it. Okay. How this 8421 came, no? Every bit position you have to take as this is, this position is 2 power 0. This position is 2 power 1. This position is 2 power 2. This position is 2 power 3. Understood? So, 2 power 0 equal to what? 1. 2 power 1 is 2. 2 power 2, 2 into 2 is 4. 2 power 3 is 8. Understood now? Okay, ma. So, how did you get this one? This one, 8421, how it has come? 1 means 2 power 0. 2 means 2 power 1. 4 means 2 power 2. And 8 means 2 power 3. Understood? If you need to get 5-digit number, okay, 5-digit number means, next question is what? 2 power 4 will be. 2 power 4 means what? It is 16. Understood, ma? 16. Like that, it will grow. Okay, ma? So, like that it will be. Okay. So, this fifth and all we no need to consider. Now, we are going to study only BCD 8421 pattern, right? Tell me for 10. How will you calculate for 10? If you add 8 and this 2. 8 plus 2 is 10. Am I right now? 8 plus 2 is what, ma? 10. So, in the place of 8, put 1. In the place of 2, put 1. Remaining position is what? Here 1, 0. In this place of 4, 1, 0. What is our final binary value? 1, 0, 1, 0. Understood? So, this is the way of calculating binary, equivalent binaries using 8421 code. Using that is what weight value. So, here what you need to understand, that, see, 1010 I told. Okay, what I said, ma? 1010. Every bit position is determined based on a weight value. Every bit position is determined based on the weight value. That is why it is called as what? Weighted code. Understood? It is called what, ma? Weighted code. You are very clear about this right now. So, like that, this table, full table we formed. Okay. Next, 5421. Like that, you tell me for 5421. Okay. So, for calculating this 3, you tell me this 3. How did you get this equivalent, ma? How did you get? Why we are having here 2 representations? 2 possible bit pattern is there. Why? For 3, can you calculate? When you add this 2 and this 1, 2 plus 1 equal to 3. In the place of 2, in the place of 1, okay, we put 1, 1, remaining will be 0, 0. Understood? Now for 5 you see, for 5, why 2 possible patterns are given? 5, see 5 is here. 5 alone is enough to determine this 5. Understood? So how can you write in this? 1, 0, 0, another one more 0. That is why you got this 1, 0, 0, 0, one possibility. Am I right? Okay. One more possibility is there for 5. 4 plus 1 is what? 5. Am I right? 4 plus 1 also 5. So in the place of 4, in the place of 1, we put 1, 1. Remaining are 0. Remaining. So you may use this, or this. Understood? Okay. So this is using 5421 representation. Next 2421 also. You see that. 2421. Any digit you take. For 5 maybe. Okay. For 5 we may take it. So for 5 you add it, ma. How will you get 5? When you add 4 plus this 1. 4 plus 1 means what will be your bit pattern? 0, 1, 0, 1. Am I right? That only you got it here, no? 0, 1, 0, 1. Okay. Don't ask the question, madam. For 5, this is the binary, like that. What bit pattern we are using? 2421 bit pattern we are using. So this also possible. This also possible using this bit pattern. Understood? Like that you have to remember. Okay. Now, but the binary means you should not say this for 5. This is what coding system? 2421 coding system. Okay. How did you get this 1011? When we add this 2, okay, this 2 and this again one more 2, again this one more 1. Okay, ma? So 2, 2, 1. That is why you got here 1, and here one more 1. Okay. So this is about what now? The bit pattern. Understood? Now another one more we see. 8, 4, minus 2, minus 1. 8, 4, minus 2, minus 1. Now you tell me for 1. for this one. How did you get this bit pattern now? Using 842 minus 2 minus 1 code, ma? 84 minus 2 minus 1 code. How will you get that 1 now? Take this 4 minus 2 equal to what? What is answer? 4 minus 2 equal to 2. That 2, this 2 minus this 1 equal to what is your value? 1. That is your 1. Okay, ma, that is this 1 actually. So, to calculate the equivalent of this decimal 1, using 84 minus 2 minus 1, using 84, this 4, this minus 2, it produces 2, with that answer, okay, 4 minus 2 equal to 2, 2 minus 1 equal to 1. Okay, that is why you got this 1 now. Okay, so, in the place of 4, in the place of minus 2, in the place of minus 1, you are putting 3 ones. Remaining will be 0. Like that, you have to go through all this. Understood? This is what about weighted numeric course. Understood, Amma? This is what about weight. So, every bit position is calculated based on some weight value. That is what weighted binary code.